I'm looking to graph this cotangent function, and I'm going to notice that it has a phase shift. First thing I want to do is remember what the graph of just the generic y equals cotangent x looks like. The cotangent is undefined where the sign is 0. So that's at 0 and pi and negative pi and every multiple of pi both directions. The cotangent of pi over 2 is 0, since the cosine of pi over 2 is 0. It's going to go up to the left, down to the right. Looks a little bit like a negative cubic function. This is negative pi over 2. And there's 2 periods of this is just the generic y equals cotangent x. And as noted, its asymptotes are at multiples of pi. So let's see, first thing that's going to happen is I have a change of period. I have a coefficient with the x, so we need to figure out the period of the new function. The period of just the cotangent function is pi, so I'm going to put that over the 1/2. Dividing fractions, I'm going to multiply by the reciprocal. So that's 2 over 1. So 2 pi. Period of my new function is 2 pi. Well, all right, let's see what we have so far then. If I do just y equals cotangent of 1/2 x, that's just for reference over there, it's still going to look the same because I haven't moved it anywhere, but it's going to stretch out. The period is now 2 pi. So my asymptotes are now multiples of 2 pi instead of multiples of pi. And the shape, well, we're stretched out, but other than that, it doesn't change. So I'm going to have a x-intercept in the middle between 0 and 2 pi is pi. In the middle between 0 and negative 2 pi is negative pi. But the shape is the same. I'm up to the left, down to the right. And there's 2 periods of just y equals cotangent of 1/2 x. Well, now we got to get the phase shift in there. The phase shift is my constant over here, pi over 8, divided by the 1/2. If you're using letters, that's c over b. And again, we're dividing fractions, so we'll multiply by the reciprocal. And we get pi over 4. Since this is positive, we're going to go pi over 4 to the left. So now I'm going to draw my final picture with all of this in there. This is y equals cotangent of 1/2 x plus the phase shift. And this is going to look like the previous one, except for everything's going to move to the left, everything, by a distance of pi over 4. So instead of an asymptote at x equals 0, I'm going to have an asymptote at x equals negative pi over 4. Move pi over 4 to the left. Instead of an asymptote at x equals negative 2 pi, It's at pi over 4 below that, so that's negative 9 pi over 4. I had to think about that one. 8 pi over 4 is 2 pi, so 9 pi over 4 is pi over 4 to the left of that. And then over here, negative pi over 4 plus 2 pi is positive 7 pi over 4. The middle, where we get the x-intercept, is going to move pi over 4 to the left. So it used to be at pi. Now it's going to be at 3 pi over 4. This one over here used to be at negative pi. Now it's at negative 5 pi over 4. Just everything moved. I'm subtracting pi over 4, moved pi over 4 to the left. The shape doesn't change. I'm going to go up and down. And I'm hemmed in on both sides by the asymptotes, same as I was before. So the shape doesn't change, just the location. So there's my final graph, and I'm going to notice where the asymptotes are. They're vertical, so they're at x equals. I'm going to name one of them, negative pi over 4, plus or minus the period to pi. The n is just there. I can go any number of periods out that I want to. So there's my final graph for this function.